Hi YouTubers. We're continuing our tests with graphite felt under so-called dry conditions, meaning I have a section of it in a dummy AA cylinder, a AA battery dummy, and in a prior video I showed you we stuffed it with some graphite felt, which was not cleaned, not nickel plated, taken right out of the bag from a commercial supplier at Amazon, and it was running for 4 consecutive days and nights. And by dry circuit, there's no electrolyte, no solvent in contact with the graphite. It's simply in a very simple circuit with a 5-watt rated LED. I'm using that because I just don't want any heat buildup or constant noise with the DC motor at this point. I'm doing preliminary tests in my office before going down to the lab. And it's working very well. A wet circuit we define as one where the graphite felt would be in contact soaked with an electrolyte such as DMF, dimethylformamide, or methyl carbonate, and lithium tetrafluoroborate as our standard electrolyte. We do supercap work, but I like to study the graphite material itself, and we're going to oxidize it or attempt to oxidize it with oxone, potassium monoperoxy disulfate oxidizing agent, and see if there's any impact on the surface area. We're interested, of course, in surface area and conductivity. And I'm also testing out here a new power supply. And my gosh, I got this from eBay for about $35 and plus shipping. And it's called Nice Power. And I'm very impressed with this. I got this, as I said, for about $35, $36 US dollars. And the company is Shenzhen Kawaki Electronic Company from China. I'll put the website down. It's nice-power.com.cn. And I'm very impressed with it. There's no fine control for this price, but you can do constant volt, constant current. And I have it running at a desired constant current of a 0.5 amp. I would never go above 3/4 of an amp with a breadboard. I just wouldn't myself. And I'll let this run. And therefore the potential is about 5.8. It'll vary a little bit in the beginning. But you can't go wrong with this inexpensive power supply, particularly if you're a home researcher. In fact, I would pick up a bunch of these to use in the lab with students. And so far, so good. And we also will be testing commercially available graphite rope. And that will be very handy in terms of flexibility. I don't know how the surface area would be, but that's why we're doing the tests. And this is available at Amazon too. Approximately 19 or 20 inches for about $1 an inch. And we'll be nickel plating this as well. And we've then studied the surfaces with scanning electron microscope at 10 to 50,000 X. I'll keep you posted on what's going on. Thanks for watching. Bye for now.